Alright, hello everybody. Today we're going to be taking a look at another dynamic programming problem. This one is a simpler one, and it's going to be more about talking about the foundation of dynamic programming in general. So this problem is going to be significantly simpler, but it's probably one of the most important problems to understand. It's very similar to the Fibonacci problem, but let's take a look at what the problem is and what it's specifically asking for. So the problem is called the climbing stairs problem. So what does it say? You're climbing a staircase. It takes n steps to reach the top. Each time you can climb either one step or two steps. In how many distinct ways can you climb to the top? In how many distinct ways can you climb to the top? So, the problem already should be kind of clear about what it's asking for, but just in case, we're going to switch to the whiteboard to have a visual example. So for example, let's say we have n steps, and the problem is asking for a specific number of steps, right? So let's say that number of steps is 3. You can choose to climb either one step or two steps. So you can either climb one step here, and then one step here. This is all the first way to climb that. Or what you can do is you can do 2 steps here, 1 step there. So that's going to be the second way. 2 steps and then 1 step. And then a third distinct way is that you could just do 1 step and then 2 steps. That's going to be third distinct way. So in total, there are going to be 3 total ways that you can approach climbing these steps. So the output for 3 stairs is 3. Alright, so hopefully you got the idea from that about specifically what the question is asking for. Now let's take a look at how we can try to solve this problem. So conceptually, in dynamic programming or recursion, what we typically do for this type of problem is do what we call a bottom-up approach. And a bottom-up approach is basically we're going to be breaking down this complex problem, which has like multiple parts. Like you have to think about, 3 steps, how would each individual part work. So to start off with, we'll just break this down into the simplest possible problem. Like let's say, what if instead of 3 steps, there was just 1 step, like that. Okay, well if there's just 1 step, then you'd just say there's 1 way. Okay, well what if there's 2 steps? Then you know that there's not just this 1 way, but there's going to be 2 ways to do it. So that means essentially not only that there's going to be 2 ways to do it by going 2 steps, but there's also going to be n minus 1 ways. So there's going to be n plus n minus 1 ways, which is 2 plus 2 minus 1, which is going to be, well, not exactly that. Ignore this part right now. But essentially there's going to be 2 ways of taking a look at this. 2 different ways of approaching a 2-step problem. Alright, so we can already see what our base case is looking like, right? So let's just start by like hopping into the code. Hopefully you kind of understand already like what the problem is asking for and our kind of method of solving it, right? So we take the simplest possible explanation, return a specific value in those specific situations, and yeah, so let's say def climb underscore stairs of n.
My mommy said no more skibidi toilets, so I left a poo-poo in her chocolate cake. This is Ohio, home of the Gritty and Rizzlers. I'm having skibidi toilet withdrawals. I'm going insane if I don't watch episode 99. I will annihilate mankind with an hydrogen bomb. Fortnite's legendary bush. Fortnite's legendary Scar Boogie Bomb. Busting like Gaia's anime transformation. I curled a pillow for 55 reps, and now I'm exhausted waiter. Can you please get me one Chug Jug and one Grimace Shake, Aiden Ross? I'm your #1 fan. I want to be a Rizzler like you when I grow up. Can you please make me your prodigy to understand the quantum mechanics of Riz and the indecencies of the neurological pathways of the conscious nervous systems, justifying the moral dilemmas of man, the ultimate judgment of character, based on forged principles.
Method in dynamic programming. How we typically do it is we create our DP table. Our DP table, dynamic programming table, is going to always contain a list of zeros. Or as you might have mentioned with our last example, it could be a matrix of zeros when we're talking about higher complexity problems. But for this thing, we're going to have a DP table of n plus 1. And we're going to be leaving the first spot blank for now, because what we're going to be doing is we're going to already be setting the first two values in our DP table. So just like this base condition here, if n is less than or equal to 2, return n, we can already put our base conditions in the DP table. So the DP of 1, that is if there's n is 1, if there's one step to climb, there's 1. If DP of 2, we can have 2. So now that we know the first two base conditions in our DP table, starting from the position 1, we're going to be leaving the first 0 index blank. Now we're going to take a look at tackling the rest of the problems. So for I in range, and remember we already computed what list of 1 is and the DP of 2 is, so we're going to start with 3, and then we're going to go all the way up until n plus 1, the length of our list. So now if we take a look at our problem, what you'll notice is that so we took a look at 1. We already know what 1 is. We also know what 2 is. 2 is going to be this. Now, how do we get to that third step right there? What is that third step going to be? Well, if you paid attention, you notice that there's going to be one way to do step of 1, and there's going to be 2 ways to do step of 2, and we're going to also realize that there's going to be an additional third way, not the third way to do it, and that third way to do it is essentially just kind of a repeat of a combination of step 2 and 1. So it's going to be a combination of step 2 and 1, because step 1 they just did by 1s, step 2 was by 2s. So to get the third way, all you have to do is combine the two. So the third method would be to go 1 and then 2. One and then 2, or 2 and then 1. So to recap the 3 ways again, we could go 1, 2, 3, which is the first way we figured out using all 1s, or we could have the second way, which was to start with the 2 on the first one and then go to 1 on this next one, or we can do the third way, which is going to be 1 and then the 2 step. So that's the third way. So what we essentially find is that the third step is just going to be this number of ways of the second step plus the number of the ways of the third step. So we can find that with just by the third example. So when we switch to the code, how that's going to look like is dp of I is equal to dp of I minus 1 plus dp of I minus 2. And we can see that for the same thing as exactly the fourth one. Now when we include the fourth step, we're going to be doing essentially dp of I plus 3, and we have an additional way. So you see all these steps that we can do, like where you do 1 and then jump to 2 and then jump to 2 and then go back to 3. There's also in the fourth way, there's going to be an additional step that we have to account for, because you can go that one additional step there. So that's why it's essentially going to be dp of, it's the same thing as solving the dp of 3 plus the dp of 2 plus the dp of 1. It's actually just going to be the dp of 3 and 2, but we know that 3 and 2 is also going to include the dp of 1, because the dp of 3 is basically dp of 2 and dp of 1. And then we're adding an additional dp of 2. So those are the total ways of approaching the thing, and we can also take a look at how this would look like for 4 real quick. We have a couple minutes left. So in 4, we'd expect what the result is going to be is that 1, 2, 3, 4, that's one way, so that's 1. We could do 2 big steps, that's 2. We could do 2, 1, 1, that's 3. 1, 1, 2, 3, and that's 4. And that's basically all the same ways. So it's just going to be the same thing, 2 plus 2 plus 1. That's going to be a total of 5 different ways to solve this approach. Now we can just, at the end of this for loop, obviously, we're just going to be returning dp of n, because the value of n that we stored in our dp table is going to be what we're returning. So now we can just run this code to test whether it's right. Climb stairs of 3, and we see, oh shoot, sorry, I didn't save it from the last problem. 3 is going to output 3. If we do 4, as we previously calculated, 4 is going to be 5 different ways, just like I mentioned. I had a whiteboard explanation for that too, but I think some of it was just me talking, and you guys didn't see my full thought process there. And then if we do 5, it'll work for previous ones. We didn't calculate this. 5 will be 8. So yeah, that's essentially how this entire problem works. Hope you guys learned something, and I'll see you guys soon. See ya.